Welcome to Exponential Chats, provided to you by Exponential Ventures. In this week's episode, we'll talk about the various infrastructure alternatives available for the development and deployment of artificial intelligence models, all and which one is best for your business. My name is Adriano Marques. I am the founder and CEO of Exponential Ventures. And today I have here with me Nathan Martins and Fernando Camargo. Starting with this episode, we're transitioning from 1 hour to 30 minutes long chats. All right, let's talk about the problem. Creating artificial intelligence often requires a lot of computing resources. This is especially true when dealing with most machine learning techniques. When starting out, most machine learning engineers quickly learn how inadequate laptops and desktops are when it comes to serving as a platform for the development of artificial intelligence models. In fact, the requirements are so extreme that even your typical server-grade hardware is inept for the job. That is why engineers have been resorting to the big guns, such as GPUs, ultra-high-speed networks, and highly parallelized distributed storage solutions. All of this comes with a price tag, and I've got to tell you, it's not cheap. There are three types of infrastructure to pick from: the cloud, colocation, and on-premise. The cloud has become the preferred type of infrastructure for essentially any kind of business in need of hardware. The three major cloud providers are Amazon, Google, and Microsoft. Part of the appeal is the fact that you're not required to acquire any physical hardware or supporting infrastructure, and you pay only for the resources that you use. This is great for most businesses because it allows for instantaneous access to hardware and infrastructure without having to figure out how to acquire and set these up. This kind of infrastructure has facilitated an uncountable number of startups and apps that benefits us on a daily basis. It is great for almost everything, but when it comes to artificial intelligence, it fails dramatically and fails in two important aspects: performance and price. Because all hardware and infrastructure are shared between different customers, you're often unable to achieve the desired performance with the hardware you're renting. And when you do, you're probably impacting the performance of someone else. And finally, there is the price problem. While startups are able to rent servers for as cheap as 0.002 cents per hour, when committing to full usage for 3 years, when it comes to hardware capable of supporting any kind of AI workload, you'll be paying $9.05 per hour on a single server. Again, when committing to full usage for 3 years, that comes up to a bill of $241,000 at the end of the 3 years with a single server and not counting the other charges related to data transfers. For that reason, cloud infrastructure has been prohibitively expensive to most companies, even big ones. Take it from NASA. They forgot to account for the cost of data transfers and ended up with the prospect of having to pay an extra $30 million to their yearly budget if they wanted to do anything with the machines they reserved with AWS. Colocation solves some, but not all of these problems. It gets most of the costly infrastructure issues out of the way, such as cooling and power redundancy, but leaves you having to acquire and manage the hardware on your own. Plus, access to the facility is not easy due to the extraneous access control measurements. And finally, you end up sharing some resources with hundreds of other companies in the same data center, which can impact your business in different ways. It is also very expensive. The monthly dues for a single rack are on average $2,500, discounting other fees that can add up based on the kind of access and add-ons you're looking to benefit from. Finally, there is on-premise. It is admittedly the hardest one to manage and with the highest upfront cost. But when it comes to artificial intelligence, it is the cheapest in the long run, the one that affords the most freedom and the most performant. Since you won't be sharing resources with anyone else, you're free to experiment and reach the capacity of your hardware without fear of racking up fees or enduring throttling. Moreover, you're in complete control of your hardware and how you want to support it. Despite the cost and performance discrepancies, I believe that different businesses will benefit more from different solutions, which is why we're having this discussion today. There's a lot to talk about here, so let's get going. Fernando, as a data scientist and machine learning engineer, can you tell us more about the typical hardware needs you face and how you typically overcome them?
Okay, sure. Well, first, when training artificial intelligence models, especially if you use deep learning, you need at least a GPU. Because if you try to train using only CPU, it takes a long time and it's impractical for most of the models. So first, I have my own GPU. I have built my computer with one GPU. I don't use it to train the models, the whole training process, but I use it to debug and everything else, so it runs much faster. And I'm worked both with on-premise and cloud services. Well, I am part of a research lab here from my university, and they have a NVIDIA DGX1, for example, that has 8 GPUs. And one problem that is very common there is how to share them between different researchers. Usually, basically, we have a WhatsApp group where you say, well, I'm picking the first GPU, another person says that he's picking the second and the third one, and so on. And one thing that's a little hard to do is to share these resources. And it's very common that one person will impact the work of the other. Like, for example, it's very common to have the disk space being full and stuff like that. And I've also worked with cloud services for other projects and companies. And in this case, I've used Google Cloud, in which I would create a VM there with a GPU, and I've also worked with TPUs. And well, it's easier in the way that you have one server, you spin it up and use it when you need it, and then you shut it down. But you have to be very cautious, because if you forget about it, it will be very expensive. And because of those expenses, we usually delete the VM when we are done, and so on. So basically, in general, you will need at least GPUs, and obviously you will need memory, a good amount of memory run, and CPU and stuff like that, so you can train your models with enough speed, basically. And yeah, I think this is it.
Yeah, it's interesting to see how it has evolved in such a way. So newest versions of the DGX, for example, I'm not sure about DGX1. It might be the same case, but I know for sure that the newest ones, they allow you to virtualize the GPU. So you can create instances inside the machine and distribute pieces of the GPU and not have anyone worry about which GPU they're working on. But still, that's something that requires work up front, and needs to be set up.
Interesting. I didn't know about that. Well, the people that are using this DGX, they are mostly researchers. So there are no one with experience with this kind of infrastructure. So maybe it's possible, but they don't know, basically.
I get where they're coming from. Like from a researcher perspective, they're just trying to run their models. They don't care how those
Yeah.
models are run. That it looks pretty much to me kind of like a colocation, where like all of you guys have access to the same machine, and if something goes wrong, one of you guys has to drive out there, fix it, all that kind of stuff.
Yeah.
It's very interesting. It's a very interesting use case. But like you said, I completely understand the lack of the DevOps kind of movement, I guess.
Yeah, sure.
Yeah, when it comes to managing those machines, if you're not getting your compute resource from a cloud provider, you're going to have to manage everything. You're going to have to know how to figure out those instances. You're going to have to do your own maintenance in those machines. And yes, NVIDIA is going to provide you support for those machines, but to a certain extent, you're going to have to figure things out for yourself, and that sometimes is not in line with the kind of effort and time that you have available to dedicate to those computers. But then again, you end up with either I pay a lot of money, sometimes money that is outside my budget with cloud, or I use a solution such as a DGX1 and I have to live with those issues. It is these days when you're buying a complete solution, like you went ahead and you bought a full GPU server using SXM4, for example, with running the newest A100s. You buy a solution with InfiniBand switch operating at 100, perhaps 200 gigabytes per second. Now you have it hooked up to a nice distributed storage solution. That's kind of like the state of the art if you want to achieve the best performance out there for artificial intelligence. And when you acquire that kind of solution, then depending on the provider of that solution, you end up with just a mini cloud service. You get everything set up, and you essentially spin up instances and start running your projects. NVIDIA, for example, they advertise their SuperPod, which is essentially this. It's a combination of DGX and one of the storage solutions that provide, there are partners with NVIDIA and provide for their customers, and Mellanox switches. So essentially get the whole bundle. A third party is going to assemble everything, monitor, provide support, and then you just come and do your processing. But when you go that route, you have to figure out infrastructure. It means cooling, power, fire suppression, access control. All of those things are a concern that you have to address and you have to manage.
Yeah, and we have to think that you have to pay upfront much more than if you were using a cloud. Like, you have to have a large amount of money upfront to build all the servers or to purchase one. But at the long run, I think it would be less expensive than using cloud, for example, especially if you use it a lot. Like if you, for example, in this lab, we are researchers, we are running models there all the time. If we were using cloud, the bills would be insane. So it wasn't really an option for us.
Right, and there's also a difference. When you go cloud, you're spending money on hardware that's not yours. So once you're done with it, there is nothing that goes back to you, nothing that you can resell, nothing that you can repurpose, recycle. It's just theirs, and you paid for it. When it comes to on-premise or colocation, then it's essentially an investment that you make for your company, and not only it's cheaper long-term, it is also something that you can depreciate and resell, repurpose, or recycle at the end of their life cycle, which is important too. I mean, when you think about it, it's comparable to owning and renting, right? When you rent, it's money that goes and you never see again. When you own, it's something that you benefit from in some way or another, and it's cheaper in the long run.
But like, in a sense, one thing that we got to keep in mind, like I come from a DevOps background, so I always think about this constantly. When you're working with the cloud, especially like cloud has been pretty much cemented into the culture now, where we can start thinking about servers as cattle and not pets. And what they mean by that is you treat computer like it's commodity. You treat hardware like it's commodity. You don't really care for it. You don't give it any special needs. You don't care for it like it's your little pet. You raise it up, you use it. When you don't need it anymore, you slaughter it. That's basically the mindset. But with machine learning, you come into this kind of complicated scenario where the hardware isn't exactly commodity. Like it's not your average everyday hardware. So it's hard to, number one, get it set up. So that's, I think, why the major cloud providers charge us a premium for using that kind of service because they spend time like setting everything up, figuring out what hardware works with what. We know that from experience ourselves that it's not easy. And the second thing is getting tools and APIs that are already cemented in the DevOps space to work with something on a colocation or an on-prem. That's no easy task as well. Like, unless you're using virtualized software to like abstract the hardware away, you're kind of like stuck figuring out yourself and then setting everything up so it works. So that way you can treat your hardware, even though it's your pet and you care for it very much, you can treat it like cattle. That's something that we also got to keep in mind when talking about this.
Yeah, and when you know that you're going to be using the hardware just for a short period of time, it makes no sense to acquire it, right? You're not looking to solve a single model that you can solve in a couple months using hardware online. You'd rather do that online on the cloud than just acquiring the whole solution, because the time that it takes is this 1 or 2 months that you would be exploring this solution is essentially the time that it would take you to just get the hardware, get it installed and running. So if you need something right away, then you have to go to the cloud. If it's something long term, then I would say go to the cloud while you figure out your exit strategy, right? And definitely when it comes to long term processing and high performance, there is no way that you can live in the cloud. Even if you have an infinite budget, the kinds of restrictions that you face on the cloud with data transfer, with storage, and with the hardware, you don't have to submit yourself to that. It's just an extra penalty over the fact that you're overpaying. So on-premise or colocation is the way to go.
I would agree with you in some parts, and I disagree in others.
All right.
My main part that I disagree is SLAs and SLOs. So in the cloud, you get a very high SLA. For those of you who don't know, SLA is service level agreement. So it's basically a contract between you and the cloud provider saying basically, hey, your service is going to be up 99% of the time, and we make sure of that. That's on a contract. That is legally binding. And I imagine for a couple of different industries or areas, or depending on your business, you need to guarantee that SLO. And that's something you just can't do with on-prem, no matter how hard you try. You can't reach that 9 nines of SLA. It's pretty hard to do at such a small scale.
You can achieve that locally. It's just very expensive. That's what we call a tier 4 data center. And in order to achieve that, then you have to have redundancy for cooling, power, and of course fire suppression and the servers. So yes, you can achieve that locally, but it just gets a lot more expensive. But here's the thing: AI is not mission critical. So so let me explain that. So when it comes to research, you don't need an SLA with 6 nines. You just don't. Mm-hmm. That's okay. You can live without redundancy. But when it comes to deployment and inferencing, then yes. But at that point, you can go back to the cloud because you don't need GPUs anymore.
Yeah.
And it's going to be a lot cheaper.
Most of the models will be trained using GPUs, but they usually don't need to be deployed in GPUs. Unless you have a given latency that you need to be below that. Your model is very heavy, very large. But otherwise, you don't need GPUs to put your models on to run.
Exactly. So when we're talking about AI, we're talking about different aspects. One is, first, is this the kind of AI that really requires a lot of resources to produce a model? Because there are different ways that you can go about solving a problem using artificial intelligence that you don't really need a GPU. In fact, you don't need a lot of resources, and you can do that with your laptop or desktop or just a regular server. But if it's that kind, that it's typically machine learning with very large models solving complex problems, then yes, you need a GPU. Yes, you need a high-speed network. You need a high-speed, high-performance distributed storage solution. Then you have no alternative but resort to that kind of hardware. But during that time that you're training, it's okay if once every full moon servers go down. It's not perfect, because if you're training for a couple of days and now you lost your work, you're going to be pissed. There is cost associated with it. But the contrary, which is a huge investment to guarantee the SLA of 6 nines for training, it's a lot more expensive and not worthwhile pursuing. So when it comes to on-prem for AI training, then you can get away with tier 2, tier 1 data center. That's the same with colocation. And then when it comes to inferencing, typically you can do that with standard server grade servers that you find on cloud providers. There's not a lot of data transfer, not a lot of bandwidth associated. Of course, it depends on what you're doing with it. Depending on the kind of inferencing that you're doing, you may need tensor cores and you may need specialized hardware. But just it is more common that you're not going to need specialized hardware than it is that you're going to need. Mm-hmm. And if you do, then that's the time that you go to the cloud.
I guess like another argument for cloud would be sensitive data, I guess, in a sense. Fernando mentioned off the air, that he was working on a camera system to detect faces. If I were feeding in my family's faces through a face detection system, I wouldn't exactly feel comfortable having this on a public cloud, at least without encryption and some very hard security requirements. So I guess that's the case for having something on-prem would be something like that. I guess if you're like in the, I don't know. But I think there are a couple of cases that we can think about.
Yeah, here in the US, if you're dealing with, for example, even non-confidential data, if you're a DoD contractor. So non-confidential doesn't mean that it can come out to the public, right? They consider non-confidential to be, for example, human resource records for government employees. You don't want that to come out. So even that level of data have to go through a certain level of certification in order for you to work with the Department of Defense or most other public organizations here in the US. There is another case, which is when you're dealing with medical records. HIPAA, it levies huge fines for any data leaks per patient, per day. So you really do not want to risk any of that. When it comes to the cloud is mostly certified for all of those applications. And when it comes to that, I don't think that it would be a huge concern if you need to prove that the data is protected to a certain level and meet the required certifications. But you may have your personal concerns and not believe in the system and not want to have your data there. And then in which case, safer bet is to have it on premise as opposed to on the cloud or in colocation. Make sense?
Yeah, indeed. For example, like you already said about medical data, I know that all the hospitals, at least in Brazil that I know of, they have their own infrastructure where they have their own servers and stuff like that. And no data, especially data that identifies a patient, can leave those servers. So that's probably one of their concerns, because there are a lot of laws that would punish them if that happened.
Right. And so let's just start to wrap up. We have 6 minutes left. Bottom line is cloud, instantaneous, cheap, depending on what you're doing. So if it's all about just web servers and regular applications, you're not doing any AI processing, you do not require lots of data transfer or training, then that's perfectly fine. That's the way to go. If your business is trying to figure out how to serve an app and how to provide all of the needed support systems around it, cloud is definitely the way to go. If you're talking about heavy processing and you're not just working on a project for a short time, you're really in this for the long run. You have a team and you're putting together uh, several projects in AI, then you're better off certainly avoiding the cloud and going on premise or colocation. Benefits between each one of them is that colocation, they're going to be offering you an elevated tier of data center. So they typically have redundant cooling, redundant power. They have a good fire suppression system. Whereas on premise, if you want to have that, you're going to have to provide that for yourself. The good news is that when you're doing AI and doing training, this is not considered mission critical, so you do not need high levels of SLA. So our recommendation is think about your use case and consider these three options in light of it. Co-location can be very expensive long run. You're essentially paying rent for an indefinite amount of time, and it's essentially $2,500 for a couple of square foot. So that's more expensive than renting in San Francisco, and you want to be aware of that. Also, access is limited. It's complex. It's not something that you can easily overcome. When servers go down, you should brace yourself for an extended period of time when you're not going to be able to solve the problem. But finally, let me just check here. Comments. I see comments from our team, and I see a question here. What is the difference between colocation and on-premise? So again, just going quickly, colocation, you essentially go to a data center and you pay rent for a space on their data center floor that is already provided with redundant generators, redundant UPS, redundant power supplies, redundant cooling system, redundant fire suppression, and all of that is ready for you to just come with your rack, put your servers in, hook them up to power, and go back home. So that's what colocation is. On premise, you're going to have to figure all of that out for yourself. Luckily, like I said, you don't need to cover all of that redundancy when you do on premise for AI, at least.
But like on-prem, you might not be stuck by yourself. There are like a couple of consultancy firms, and they're like DevOps companies that you can revert to help you get everything set up. People who know how to do this. So I wouldn't say you're completely on your own, but you're gonna have to figure out. If you're not gonna figure out yourself, you're gonna have to pay someone to figure it out for you.
You're absolutely right. And it's not like you're going to have to learn all of this and do or hire a new employee to deal with it. Like Nathan said, can hire someone. You get certain levels of support from that company. Things go south, you call them, they come and solve the problem. You don't have to deal with it. So, but it's an additional cost that you have to account for. That's for sure. Very nice. So, thanks for the comments, guys. I see a few other comments here. Very nice to see participation. Like I said in the beginning, this was supposed to be a shorter version, just 30 minutes. We're experimenting with it. Let's see how it goes. Give us some feedback. Let us know if you like it. And let's see each other again next week. Take care, guys.
Bye.